The process of subnetting a network may look a little difficult at first glance, but the reality is that we are using the same techniques we used when we did our binary math video. We're simply combining them and separating this out on the screen and performing some very, very basic math when we're stepping through this. Let me give you an idea of how you could take an IP address, in this particular case, 192.168.1.0, and have a subnet mask of 255.255.255.0 and calculate how all of this would be subnetted out. What we'll first do is take those two IP addresses, the IP address of the device and the subnet mask, and we'll write out their binary representation right here on the screen. And what we've done is separate each octet, and we've written the binary compatible of that. So 11000000 is 192. 168 is the same as 10101000, and so on. We write all of that out on the screen. And what I've also done is put in blue here which parts of these are the network address, because that is your subnet mask, that's your network subnet. And then everything else that's not the subnet mask, I've qualified as being the host, and I've colored that with that other color and put an H next to it so we can keep track of that. Whenever we're looking at the mask, you know the mask is always going to have these ones here, and we talk about the network address being masked by those ones, and that's why I put those ins right there so we would know that was the network. Everything that is not masked by the ones is therefore the clients that you would have on that subnet. So that's how the IP address and the subnet mask work together to be able to tell your computer what network am I on and what IP addresses should I expect to see on my local subnet. If we look at those last 8 bits, we could take those 8 bits and calculate out what that final value is. And if you were to do that, and you can do it very quickly in your head, you know that all 8 of those bits together would be 255. So we know that there are a total number between 0 and 255 of 256 total IP addresses that you could have in this range. But of those, we take 2 away because one of those addresses is the address of the subnet, and another one of those addresses is the address of the broadcast address of that particular subnet. That means that we do not have 256 possible clients on this network. We have 2 less than that, which is 254 possible clients on this network. So as we're going through the calculation of this, just keep in mind that we figure out what the total number will be. We get rid of the subnet address, we get rid of the broadcast address, and everything that's left over is the total number of IP addresses assigned to devices that we can have on that subnet. Let's take another example. Someone may say to you, here's the IP address of a device and the subnet mask that device is using. What network is it on? And we perform exactly the same calculation to determine that. We take the IP address 192.168.1.165, write out the binary equivalent. We take the subnet mask, write out its binary equivalent. And then, of course, we're performing what we call a bitwise AND, which means every time there is a 1 in that subnet mask and a 1 in the IP address itself, we're going to bring down a 1. Anytime there's a 1 or a 0, and it doesn't matter which direction there's a 1 or a 0, we're going to put a 0. So the only time there should be a 1 left over is in both the IP address and the subnet mask happen to be a 1 on here. And if we calculate that out, we just take whatever the resulting number was there and we calculate out 192.168.1.0. We perform our binary to decimal calculation back and forth, and that address is what we call our subnet address or our network address. If we take this same number and what's left over, and everywhere there was a 0 for the host, we change all those zeros to 1s, and we again perform that conversion from binary to decimal, we end up with the broadcast address for this network, which is 192.168.1.255. So just by doing this bitwise and bringing down that number, we were able to automatically calculate for us what the subnet address was, and by changing all of these bits to a 1, we were then able to understand what the broadcast address was. If we summarize all of this on a screen, then we've got our IP address of 192.168.1.165 and the subnet mask. We calculated out the subnet of 192.168.1.0. That's our subnet address, and our broadcast address of 192.168.1.255. And if we had taken those 8 bits at the end were for our host and calculated that, we would have come up with 256 total between 0 and 255, and we would have subtracted the 2 addresses for our subnet and for our broadcast, leaving us a total number of hosts on this network of 254. And if we needed to start assigning IP addresses, we could assign IP addresses anywhere in the range of 192.168.1.1 through 192.168.1.254. And a good sanity check for us then would be to look at our original IP address and determine, is it in this range? And if we look, 192.168.1.65 is certainly in the range between those 2 particular IP addresses. Let's perform the same calculation, but let's use a different subnet mask this time. This address will be 10.11.12.13. That particular IP address is on a network that has the subnet mask of 255.255.0.0. And of course, we could use CIDR block notation to write this 10.11.12.13/16 because we're using 16 bits of that subnet mask. And again, if we were to write this out in binary form, 10.11.12.13 has this binary equivalent, and 255.255.0.0 are written out in binary here. And again, I've taken my network address and made it the blue color, and I've taken my host addresses and made them the gold color. And again, we're going to perform that bitwise AND function, and everywhere there's a 1, I'm going to bring down the 1s. Every time there is a 1 and a 0, or a 0 and a 0, I'm going to bring down 0s, and we have this binary number that we've created by doing the bitwise AND. And by then performing a binary to decimal conversion, our subnet mask, or our subnet that we have, has an IP address of 10.11.0.0. That is our subnet address. And if we take all of those particular zeros that are there and we create them and make them 1s and perform the same conversion, we come up with the subnet broadcast address, which is 10.11.255.255. So there's the first 2 numbers we need, which is our subnet address, our network address, and the broadcast address for that subnet. Summarizing this again, we've got our IP address of 10.11.12.13 and the subnet mask that is 16 bits long. We calculated our subnet address to be 10.11.0.0 and our broadcast address to be 10.11.255.255. And that means anything in between those 2 will be the hosts on this network. If we were to calculate out all of those hosts that we had in that original address, we had 16 bits of network and we had 16 bits of hosts, and that happens to be 65,536. We subtract our 2, that brings us to a total of 65,534 hosts that we can have on this network. And our sanity check, let's check and make sure 10.11.12.13 is in this range. Well, 10.11 is in the front of both of these. We take the third octet 12. Is 12 between 0 and 255? It certainly is. And is 13 in between 1 and 254? It absolutely is. A network or designing a network, we need to determine how many networks we're going to need and how many hosts we would want to have on each of those subnets, because you really can't change this once you have it in. You're really designing this to be applicable to almost any occasion where you might have a need to assign some IP addresses and create some networks on that particular network. So we generally ask the question of how many networks do we have and how many hosts per networks do we have as well, or how many will we like to have on each individual network. Let's do an example of one of these and see the process we might go through. Let's say we're building a brand new site. This particular site has a router, and I've got 4 separate subnets that happen to be in this particular site, but we've not assigned any IP addresses to those yet. And our provider has given us a block to use. They've given us 192.168.1.0 with a subnet mask of 255.255.255.0. And if we were to also write this out in CIDR block notation, it would be 192.168.1.0/24. Well, they've given us one subnet, but the reality is we have more than one subnet we would want to use. We need a scheme that's going to allow us to support at least 4 networks. And in this particular example, each one of those networks has about 40 devices. So we need to find a way to take the network number that we were given and subnet it a little bit more so that we're able to get exactly the right number of networks we need and exactly the right number of a host that we would need per subnet. Let's have a look at how we would do that. One easy way to help us make a decision here would be to write out every single one of our options. And in this particular case, we've been given a subnet mask of a /24. And if we were to use that particular configuration, that would give us one network that we could potentially put 254 hosts on. But we know that we need more than that. We need at least 4 networks with about 40 systems per subnet. And if we were to perform the same calculation on each mask, we take a /25 and a /26 and a /27, 28, and so on. We can also then calculate out how many networks that would be and how many hosts per network that would be. Now, our magic number is 40 systems per subnet. And if we were to look at our options of how many hosts per subnet, well, we know we couldn't use a /28. That only allows 14. We couldn't even use a /27. That only allows 30 hosts per subnet. But you'll notice a /26 would allow us 62 hosts per subnet. In fact, it also comes out to subnet to our magic number of 4. We need 4 networks. If we were to subnet to a /25, that would allow us also to have 126 hosts per network. That certainly meets our requirements for having 40. But notice that it would only create 2 networks for us. That doesn't work either. We need at least 4 different networks. This /26 looks to be the number that we would like to use. Let's go through the process of understanding the calculations of this and how you would figure out what those subnets would be. In this particular case, we've decided on that /26 that happens to be 192.168.1.0. And instead of using the assigned subnet mask of 255.255.255.0, we've changed that 0 to a 192. We essentially added on 2 more bits to the subnet mask, and that's how we're going to use this IP address. If we were to write these out, 192.168.1.0, there's the binary equivalent, and the 255.255.255.192 is written out in this binary equivalent. Now you can see where we're getting the /26 from. It's this 24, 25, and 26 ones that we happen to have here. And those extra ones I've colored purple so you can see them because they are also now part of that network address, but I made them in different colors so you could see those were the ones that we assigned for that particular subnet masking on our network. And in the summary, there's the same view of that calculation we had on the previous slide with the /26 having 4 networks and 62 hosts per network. Let's now take this calculation that we've created in this last octet and figure out what the subnets might be. And what we're going to do is take a look at the network that we have assigned here of these 2 bits. So we'll start with 00, and we'll assume the rest of the numbers we will not be using. They'll simply be zeros because they're part of the host address. So 00 and all zeros is 0. 01, 00000 is 64. 10 and all zeros is 128, and a 11 is 192. So those will be, at least in that 4th octet, what the network addresses or the subnet addresses will be when we start writing these out. Now let's reverse this and look at all of these bits that we've got left over, these other 6 bits that we have, and let's go and have a look at what the range would be between making all of those 0, and if we calculated it out, that of course would be 0, and if we calculated out 11111111, we have 63 there as the total number that we'd be able to use. So we've got hosts that would range between 0 and 63. That would be 64 total addresses per subnet. Let's write all of these out. And although there's a lot on the screen here, what we've really done is perform one calculation after another after another. So this is something you can easily do on a piece of paper. We're using our IP address of 192.168.1.0 and our net mask of 255.255.255.192, or 26 total bits of a subnet mask. And remember, we calculated out the total number of hosts per network, and I calculated between 0 and 63. So obviously that would be 64. And we subtract 2, of course, one for the network address and one for the broadcast address. So let's try the first one, which would be 192.168.1.0/26. And we'll perform exactly the same functions that we did before by calculating this out. When we calculate that, we come up with a broadcast address of 192.168.1.63. And then, of course, that means that our minimum number of a host address on here would be 192.168.1.1. And the maximum IP address on that local subnet would be 192.168.1.62. Well, we know the broadcast went up to 63, so the next number is going to start the network address for the next block. And if we were to perform the same calculations for the network 192.168.1.64, we would come up with these broadcast addresses, a host minimum that was 1.65 and a host maximum of 1.126. And then we perform the same function again and again, all the way until we get to the end of the range that has been assigned to us. So just by following some simple mathematics and going through each possibility of a subnet, we were able to then calculate out exactly what we would put in each network. So for this network, we'd have 192.168.1.0/26. Here's another network range of 192.168.1.64/26, of course. Another range that was 1.128 and another range of 1.192. So by taking those 26 bits of a subnet and simply performing the same calculation over and over, we were able to create an entire series of 4 networks, all separated out with exactly the right number of hosts per network.